Welcome to section 4 of unit 1, and in this section we'll be looking at differentiation of other functions. By the end of the session you should be able to appreciate the concept of derivatives of other functions and determine the derivatives of sine, cos, and logarithms. So let's look at the derivative of some common functions. So the derivative of any constant is 0. The derivative of any function such as x is 1, and the square of any variable, remember it doesn't have to be x, it could be v, it could be m, it could be z, it could be a, any letter. So this derivative of x squared will always give us 2x. The square root of any function, the derivative of any square root of any function will always give us 1 over 2 times x to the power minus 1 over 2. Then when you look at the exponential, the derivative of any exponential will always give us that same function. So e to the power x will always give us e to the power x. A to the power x will always give us a to the power x. And that is the natural log of a. And when we look at logarithms, the natural log of x, the derivative of the natural log of x will always give us 1 over x. The derivative of any logarithm base a x will give us 1 over x multiplied by the natural log of what? A. Trigonometry, that is looking at the cosine, tan, and then the cosine, tan, and then the sine. Note that the x is in radians, so the derivative of any sine x will give us cos x. The derivative of any cos x will give us negative sine x. The derivative of any tan x will always give us sec square x. Then the derivative of any sine to the power minus 1x will give us 1 to the power square root of 1 minus x squared. And the derivative of any tan to the power minus 1 x will give us 1 over 1 plus x squared. Now let's look at some of the rules of differentiation. We have multiplication by constant, we have the power rule, the sum rule, differential rule, product rule, quotient rule, reciprocal rule, the chain rule, and the chain rule is as a composition of functions. We can also have the chain rule in different form. So we'll be looking at all these rules one after the other. Now, the power rule. With the power rule, which we've already looked at earlier on, we said that when you are given a particular function, let's say x to the power n, then we are going to have n multiplied by x to the power n minus 1. I made mention of this formula earlier on, but I didn't specify it was a power rule because I knew we were coming to this section as well. So when you are given a function x to the power n, then for you to find the derivative of that function with the power rule, all we are saying is use the general formula n to the power n multiplied by x to the power n minus 1. So therefore, if I have an example as this, then it's going to be 3x squared. The same way, if I have 1 over x, then we know that 1 over x is also x to the power minus 1. And when we do that, it becomes easier to find the derivative of the function, which will give us minus x to the power minus 2. Now multiplication by constant. So we have 5x squared. What will be the derivative? So here, first of all, we have to solve for x cubed. So what will be the derivative of x cubed? We said earlier on is going to be 3x squared. So we simply multiply the 3 by the 5, which will give us 15x squared. Now the sum rule says the derivative of f plus g, that's the function of f and the function of g, will be the derivative of the function of f then the function of g, then we add them together. So if we are going to find the derivative of x squared plus x cubed, then we have to look at the derivative of x squared alone, the derivative of x cubed alone, then we add them together. So in this case, we are going to have x squared going to give us 2x, x cubed going to give us 3x squared, and then we can now add them to get the derivative of the function x squared plus x cubed. The difference rule. The difference rule says if we have a function f and g and we are subtracting, then we have to subtract their respective functions. So we can work out each derivative separately and then subtract them. Using the power rule, we want to determine the derivative of v cubed and then v to the power of 4. So we first of all have to find the functions or the derivative of v cubed, which will give us 3v squared, and 4v to the power 4, which will give us 4v to the power 3. So if we want to find the derivative of the function, then we can just add these two together, which will give us 3v squared minus 4v to the power 3. So remember, it doesn't have to be x, it could be any letter. It could be any letter. What will be the derivative of 5z squared plus z cubed minus 7z to the power 4? So applying the same concept, you realize that we are going to find z squared to be 2z, z cubed to be 3z squared, z to the power 4 will give us 4z cubed, and we can now multiply their respective. So 5 multiplied by the 2 here will give us 10z. Then we have 3 multiplied by 1, because remember here is just 1, which will give us 3z squared. Then we have 7 multiplied by 4 here, which will give us 28z to the power 3. So the difference rule is saying that just find the function separately, find the derivative of the function separately, and then you can now subtract them. Now the product rule. The product rule is saying that when we have a function f and g and we want to multiply them, then we have to first of all find the function of g. So we have to find the derivative of this and multiply by the original function of f. Then we find the derivative of f and multiply with the original function of g. Then we can now add the two together. In our case, f is equal to cos and g is equal to sine. So we know that from the table above, if you want to find the derivative of a cos x, it will always give us minus sine x, and the derivative of any sine x will give us what? Cos x. So the derivative of cos x sine x will give us cos x minus sine x, which will give us cos square x minus what? Sine square x. So we can also look at the reciprocal rule. What is the derivative of 1 over x? This rule is saying that 1 over f is equal to negative the function of f, the derivative of the function of f divided by f squared. So with f of x equal to x, we know that the derivative of f of x is always going to give us what? 1. So the derivative of 1 over x will give us minus 1 over x squared, which is the same result we got above using the power rule. Now we can also look at the chain rule. The chain rule. So what is the derivative of sine x squared? Sine x squared is made up of sine and x squared. So f of g will give us sine g and then g of x, which is equal to x squared. So the chain rule is saying that the derivative of this particular function will give us this. So the individual derivatives are the derivative of x multiplied by g, which will give us cos g, and that is this one. We said that the derivative of any cost will give us any sine x or sine g will give us what? Cos g, and then the derivative of this, which is g into brackets, that is a function of g, which is x squared. The derivative of x squared will give us what? 2x. So the derivative of sine x squared will give us cos the function of g of x times what? 2x, which will give us 2x cos x squared. Another example to illustrate this is, what will be the derivative of 5x minus 2 all to the power 3? The chain rule says, first of all, find the derivative of the function f of x. So we know that 5x minus 2 to the power 3 is made up of g to the power 3 and 5x minus 2. So to find this, we realize you will see that the function f of g is equal to what? G cube, and g of x will give us 5x minus 2. The individual derivatives are the function or the derivative of f of g, which will give us 3g squared, and that is by the product rule, and g of x, the function or the derivative of the function g of x will give us what? 5. So at the end of the day, we are going to have 3g into brackets x squared times 5, which will give us 15 into brackets 5x minus 2 all to the power 2. Now with the notation, now we've been talking about shrinking towards 0 or heading towards 0. This is actually written as a limit like this. So we write lim, which is the limit, change in x approaches, or the change in x as it approaches what? 0. Then we write the functions attached. So the derivative of f equals the limit as the change in x goes to 0 of any function, or the change in y-axis as we saw earlier on, over the change in what? X. Or sometimes the derivative is written like this, dy over dx, which will give us this, the function that's a change in y over the change in what? X. And the process of finding a derivative is what we call differentiation. So I hope you understand the various rules of differentiation, and as we go to the next session, you'll also learn about the different integration of other functions as well. I hope to see you in the next session.